Notes on Chapter 7, Section 5. This is Part 1. Solving square root and other radical equations. Alright, first let's identify a radical equation. So a radical equation is an equation in which at least one variable expression is stuck inside a radical. Usually a square root. Not always, but usually. Okay, we typically work with the square roots because if you're using higher roots, the process is pretty much the same. So a radical equation is an equation in which at least one variable expression is stuck inside a radical, usually a square root. So if I look at this example, my variable expression is x, and it's stuck inside the square root. Over here, this is not a radical equation because the variable is not stuck inside the radical. All right, square root of 2 is a real number. It's some decimal. And here it says, or a variable with a rational exponent. We know those are radicals incognito. We just finished doing that section. Rational exponent. You know, like x to the 1/2 power. Well, x to the 1/2 power is really the square root of x. If the radical has index 2, which means square root, okay, then the equation is a square root equation. Okay, so if the radical has index 2, then the equation is a square root equation. Like this first one here, that's a square root equation. It is a radical equation because the variable or variable expression is stuck inside. Versus this is a non-radical equation. Here, this is easy to solve for x. We just subtract the square root of 2 to the other side. So you have to be able to recognize what a radical equation is. And then when we get to solving these, you just use inverse operations all the time. Like when we're solving a, equation like 2x plus 5 equals, 13. What do we do to solve for x? You do inverse operations, and it's PEMDAS in reverse, right? So we take care of any addition and subtraction first. So this is being added, so we subtract it. We get 2x equals 8. And the operation here is multiplication, so the reverse or the inverse of multiplication is division. That's when we divide. And we see x is 4. And we solve the equation by using inverse operations. We're going to do the same thing with the radical equations. All right, examples of solving square root equations. We have a few on here. First one, well, I need to get the radical by itself. There's a 2 in front of it, and there's a negative 12 behind it. I must get rid of those first. I'm going to do one step at a time. 2 times the square root of 5x plus 1. Notice the x is inside the radical, so I have to isolate this thing to get it out. So I'm going to add 12 to the other side. To get rid of the 2 is being multiplied with this expression. And so I divide and get the square root of 5x plus 1 equals 6. What's the inverse operation of square root? right? It's all about inverse operations, right? I added the 12, that's the opposite of subtraction, and I divided the 2, that's the opposite of multiplication. Well, the inverse of square root is squaring. Now, when I square this square root of 5x plus 1, I'm left with 5x plus 1. You can't forget to square the other side. That's 36. And the rest is just a basic equation, just like I solved this equation. Subtract the 1 over, 5x equals 35, and divide, x is 7. Now, you must check these. You have to check these because sometimes your solution, when you substitute back in, it gives you a not real number. So you do have to check these. You must. All right, so I got 2 square root of 5 times 7 plus 1 minus 12 equals 0. 2 times square root, well, that's 35 plus 1 is 36, minus 12 equals 0. The square root of 36 is 6 times 2 is 12. This is 12 minus 12, which does equal 0, so it works. Okay, and then and only then can I say that 7 is my solution. All right, why don't you pause the video and try example 2. Okay, well, hopefully you pause the video and try this one on your own. Notice the negative 10 was stuck out front, so we have to add it to the other side. When I do that, I get the square root of 2x plus 1 equals 5. Now the radical expression is by itself. It's isolated. So now I can square both sides, and that's what I have here in red. Okay, when you square a square root, it takes away the radical symbol because they're inverses of one another. It gives me the radicand 2x plus 1 equals, don't forget to square the 5, 25. Solving by subtracting 1, then dividing by 2, I see that x is 12. And when I set up and show my checking by substituting the 12, the solution, in for x, I get negative 10. 2 times 12 is 24 plus 1 is 25. The square root of 25 is 5. And negative 10 plus 5 is negative 5, so it works. All right, let's do example 3 together. It should be quick. I'm going to subtract 7. I get the square root of 2x minus 1 equals 3. I'm going to now square both sides to get rid of the radical. The left side is 2x minus 1. The right side is 3 squared is 9. Add 1 to the other side, 2x equals 10. Divide, x is 5. Do the check. So when I'm checking this, I'm doing 7 plus square root 2 times x is 5 minus 1 is 10. This is 10 inside the radical, minus 1 is 9. The square root of 9 is 3. So this becomes 7 plus 3, or 10, and that does equal 10. Okay, so if you have any questions, please be sure to ask so that I may help you. All right, side 2 of our notes. Solving radical equations with rational exponents. Remember, the rational exponents are really radicals in disguise. When solving a radical equation with a rational exponent, you raise each side to the reciprocal power. And it's the reciprocal of that rational exponent. And here, you need to remember when to properly use plus or minus. That's for even root radicals, okay? Only the evens. The odds only have one. Odd indexes only have one real root. All right. So again, you cannot raise to the reciprocal power until the expression is isolated. In other words, if I look at example 1, there's a 2 in front of my quantity being raised to the 3/2 power. The 2 is not being raised to that power. If it was, it would be, in here with it in parentheses or brackets or some kind of grouping symbol. So the only thing being raised to the 3/2 power is quantity x plus 3. You must remove the 2. So always remember that you have to isolate it first. All right, so I'm going to divide. I get quantity x plus 3 to the 3/2 power equals, now I'm going to divide, right? I'm going to divide this by 2 because it's 2 times this. The inverse of multiplication is division. 54 divided by 2 is 27. Now, what we do with these problems is we're going to raise each side to the reciprocal of this power. Now, the flip of 3/2 is 2/3. Okay, my goal is to make this exponent become a 1. So if I multiply 3/2 by 2/3, I get 6/6, which is 1. Okay, so it drops out that radicand, if you will, for me. So I get x plus 3 equals, now this is 27 raised to the 2/3 power. And we know power over root. This is a cube root. So we do not use plus or minus. Okay, we're taking the cube root on both sides. We do not use plus or minus. So I'm going to rewrite it as the cube root of 27 squared. X plus 3 equals. So again, on the left side, we have the x plus 3. And over here, cube root of 27 is 3. And 3 squared is 9. Now we're going to subtract the 3. X equals 6. You must check these. These are radical equations. It's not, and you need to be checking these in your homework. 2 times quantity, 6 plus 3 to the 3/2 equals 54. Now, 6 plus 3 is 9. This is the square root of 9, which is 3. 3 cubed is 27 times 2 is 54. Or type it on the calculator, but you have to be able to type it on the calculator correctly. Example 2 is very similar to example 1, so please pause the video and try this one on your own. Write in pencil in case you have to erase. Okay, hopefully you paused the video and did this problem on your own. This is 3 multiplied with this being raised to the 3/5 power. 3 is not being raised, so divide. I get x plus 1 to the 3/5 power equals 24 divided by 3 is 8. I have to remove this power. The only way to do it is to raise it to the reciprocal power, 5/3, on both sides. The left side becomes x plus 1. The right side, okay, this 8 to the 5/3 power is the cube root of 8 raised to the 5th power. Okay, cube root of 8 is 2, and 2 raised to the 5th power is 32. Subtract the 1, I see that x is 31. Now remember, you must check these. I put 31 in for x. 31 plus 1 is 32. The 5th root of 32 is 2. 2 cubed is 8. This becomes 3 times 8. And 3 times 8 is 24. It works. So let me know if you have any questions on that. All right, moving right along, we'll go to example 3. Very similar. Again, the only thing being raised to the 1/3 power here is the x minus 9. So I have to get rid of the 4. The 4 is attached by multiplication. The inverse multiplication is division. So I've got x subtract 9 to the 1/3 power equals, remember I'm dividing, so the 8 becomes a 4 when I divide. The 8 becomes a 2 when I divide by 4. Now I'm going to raise each side to the reciprocal power. What's the reciprocal of 1 over 3? Well, it's 3 over 1. And 3 over 1 really is 3. Okay, so I wrote it as a fraction over here to illustrate, since this was a fraction. And since I know 3 over 1 was 3, I'm going to cube the 2 on this side. Left side, I'm left with x minus 9. 2 cubed is 8. Add the 9, x is 17. Now, sometimes you do get extraneous solutions with these, so it is important to check. For parenthesis, my x is 17. There's the minus 9. There's the 1/3 equals 8. Now remember, we didn't use plus or minus here because we're not even taking a root, right? There is no first root. That's 3 over 1, power over root. We're just raising it to the power, in case you were wondering. All right, 17 subtract 9 is 8. The cube root of 8 is 2. So this really is 4 times 2. And so we do see that 8 equals 8, and it does work. It gives us a true solution. All right, the next one. A couple of different things, because what's being raised to the power is not a quantity this time. So that's different. But remember, this, only the x, is being raised to the 2/3 power, not the 2. See, because if the 2 was being raised, then it would look like this. Okay, so you have to understand the difference between this and this. Okay, here the 2 is included in being raised to that power, but here it is not. And before you can take any reciprocal power, raise it to a reciprocal power, you have to have that item by itself. All right, so I'm going to say x to the 2/3 power equals 128 divided by 2. Well, that's 64. Now I need to eliminate and get rid of that 2/3 power. So I'm going to raise both sides to the 3 over 2 power. Now if I look here, that's an even root. This is square root. You need plus or minus. You must have it. Okay, so you always have to determine, do I need the plus or minus or not? Yes, you do, because you're technically taking the square root of both sides of the equation. The left side simply becomes x, right? X to the 2/3 raised to the 3/2, power to a power, you multiply. That's 6 over 6, or 1. Equals plus or minus. This becomes the square root of 64 cubed, right? Power over root. X equals plus or minus, well, the square root of 64 is 8. I didn't cube it yet. X equals plus or minus, well, 8 cubed is 512. You could use a calculator for that. So now we're going to check. We actually technically have 2 solutions here because of the plus or minus. X equals negative 512 and x equals positive 512. All right, first check. 2 parenthesis negative 512 2/3 power equals 128. I can take the cube root of a negative. The cube root of negative 512 is negative 8, and negative 8 squared is 64. 2 times 64 is 128. Then we check the positive case. You're going to get the same thing. The cube root of 512 is 8. 8 squared is 64 times 2 is 128. So it works for that one as well. So in this example, I had two solutions because I had to use plus or minus. Okay, so you always look at the denominator of what you're raising the reciprocal to, okay? So the denominator here was 3, that's cube root, no plus or minus. 3 cube root, no plus or minus. This one, the denominator was 1. It wasn't even. We weren't taking any root, so no plus or minus. This was a 2, so any even, you need the plus or minus. Okay, so if you have any questions, please let me know. You will have 2 assignments to do over the course of 2 days. Day 1, so that you can get some feedback on as to whether or not you're doing these correctly, and then day 2 to do a few more of those so that you get better acquainted with it. Okay, so you'll have, I think, 1 through 12. And then we're going to continue notes 7-5, part 2. Got any questions? Please let me know. Have a great day.